Welcome back to Arxflix. Today, we're diving into a fascinating paper titled ConsistI2V, Enhancing Visual Consistency for Image-to-Video Generation. This research tackles a major challenge in image-to-video I2V generation, maintaining visual consistency throughout the video. As you can see in this figure, existing methods often struggle to preserve the integrity of the subject, background, and style from the first frame, leading to inconsistencies and unnatural motion. Let's delve into the problem. Traditional I2V methods often rely on simple conditioning schemes, directly concatenating the first frame's latent features with the input noise. While this improves appearance alignment, it fails to address the issue of generating videos with incorrect and jittery motion. ConsistI2V proposes a novel framework to enhance visual consistency in I2V generation. It focuses on improving the first frame conditioning mechanisms and optimizing the inference noise initialization. Here's a visual representation of the ConsistI2V framework. The model utilizes a net architecture with spatial and temporal layers. The first frame's latent representation is injected as a conditional signal, enhancing the model's ability to generate videos that closely resemble the initial frame. ConsistI2V introduces two key innovations. The first innovation is fine-grained spatial feature conditioning. The model augments the spatial self-attention layers with features from the first frame, allowing each spatial position in all frames to access complete information from the initial frame. This enables more precise and detailed conditioning. This figure illustrates how the spatial self-attention layers are enhanced with cross-frame attention mechanisms. The second innovation is window-based temporal feature conditioning. The model incorporates a local window of features from the first frame into the temporal self-attention layers. This helps the model attend to the same entity in the first frame when performing temporal self-attention, ensuring smoother and more coherent motion. As you can see, the temporal self-attention layers are augmented with a window of first frame features, allowing the model to capture the movement of objects across frames. ConsistI2V also introduces FrameInit, a novel inference noise initialization strategy. It leverages the low-frequency component of the first frame image to guide the generation process, ensuring a consistent layout and eliminating the noise discrepancy between training and inference. This figure shows the different frequency bands after spatiotemporal frequency decomposition. The low-frequency component represents the overall layout, which is used by FrameInit to stabilize the video generation. The paper evaluates ConsistI2V on various benchmarks, including UCF 101, MSRVTT, and a new benchmark called I2V bench. The results demonstrate that ConsistI2V significantly outperforms existing methods in terms of visual quality, consistency, and video-text alignment. This figure showcases qualitative comparisons between ConsistI2V and other baseline models. ConsistI2V consistently generates videos with subjects that align with the input first frame and exhibit more natural and logical motion. Ablation studies confirm the effectiveness of each component of ConsistI2V. FrameInit, spatial first frame conditioning, and temporal first frame conditioning all contribute to the model's superior performance. This figure shows the impact of disabling different components of ConsistI2V. The results highlight the importance of each component in achieving visual consistency. ConsistI2V's innovations extend beyond I2V generation. It can be applied to autoregressive long video generation and camera motion control, demonstrating its versatility. This figure illustrates how FrameInit can enhance object consistency in long video generation and enable training for camera motion control. ConsistI2V represents a significant advancement in I2V generation, addressing the critical challenge of visual consistency. Its innovative conditioning mechanisms and noise initialization strategy pave the way for more realistic and controllable video generation. That's it for this Arxflix summary. If you found this video helpful, please give it a thumbs up and subscribe for more academic paper breakdowns. Thanks for watching. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.